Section 5.1 and 5.2 we're going to do at the same time. Just pulling stuff from each of those sections if you want to read those in the book. But basically it's over polynomials. So let's first talk about what's the definition of a polynomial. So a polynomial, is of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 all the way down to a sub 1 x plus a sub naught, where n is a non-negative integer. Basically, what it is, we just start here with our highest order term. All the a's are just coefficients, but then we start with our highest order term and we go in descending order. With the exponents of the polynomials. Okay, so then when we talk about degree of a polynomial is determined by the highest exponent. For example, this is a 5th degree polynomial because the highest exponent is a 5th degree polynomial. Now this one is written in standard form. If something is out of order, not in standard form, it's still going to be the highest degree polynomial or exponent. So now it's written out of order. The highest degree exponent is 7, so that determines the degree, 7th degree, but it needs to be in standard form. You just rewrite it with the highest and then descending down. Now, we're going to talk specifically about something we know and kind of work into some harder things. This whole chapter kind of hinges on what polynomials are and how to solve them. So let's first talk about a quadratic. We know that quadratics have a graph shape that looks like this. This is called a parabola, or it could be upside down. The very lowest point or the very highest point is called the vertex. Okay? So we want to learn how to find the vertex of these guys. So with a quadratic, we have something called vertex form. If something is in vertex form, it looks like this. This is a certain form of a quadratic. If it's in that form, the vertex is HK. Okay, but they're not always in vertex form. Here's an example of one in vertex form. We know that that very highest point or lowest point is going to be determined by what it looks like in vertex form. So here, using what that just said, the vertex is going to be at 2, 5. So we know that's going to be that very highest point or that very lowest point. We'd have to graph it to know if it's going to be a high point or a low point. Now, if something's not in that form, we have something else that helps us. If something's in the standard form of a quadratic, we have something called the vertex formula. This is more likely what you're going to use. It's negative b over 2a, and then we take that certain x value and plug it into the function to get a certain y value. Okay, for example, let's say I have f of x is 2x squared plus 4x plus 5. Okay, if I want to find the vertex, we want to first find negative b over 2a. This will be negative 4 over 2 times 2, which is negative 4 over 4, which is negative 1. Then if I find negative b over 2a, this is going to be f of negative 1, which is 2 times negative 1 squared, plus 4 times negative 1, plus 5, which if you put all that in your calculator or do it in your head, whatever you like, it's 3. So the vertex of this guy is at negative 1, 3. Okay, so let's do a application problem. Let's say, first off, this comes from physical science. I don't know how many of y'all have taken physical science. This is not a physical science course, so I'm not going to expect you to remember this formula. But this is used to determine, this is a T right here, used to determine something that's thrown or shot into the air that's acted upon by gravity. This guy right here is initial velocity, how fast it's initially shot or thrown. And this is the initial height, how far it is above the ground that it will land on at the end of said time. Okay, so with the initial velocity, if it's shot out of a cannon at whatever speed, that's what your initial velocity is going to be. But let's say you're standing on a cliff and you just drop it, your initial velocity is going to be 0 because you're not throwing it, you're just dropping it. And if you're standing on like a 100-foot tall cliff, your initial height is going to be as high as the cliff is. Okay, so let's have an example here. Let's say you're standing on a cliff at the end of the semester because you're happy you're done with school, and you throw your math book off, and you throw it, you're at a height of 100 feet, and you throw it up at 80 feet per second. We want to know how long will it take to reach its maximum height, and what will that maximum height be? Well, we just plug everything into this formula, and we know that that maximum height is going to make a shape kind of like that, and we're going to find that guy, which is going to be the vertex. Okay, so we have negative 16t squared plus 80t plus 100. 80t being our initial velocity, we threw it up at 80 feet per second, and we're standing on a 100-foot tall cliff. Okay, so if we find negative b over 2a, that's negative 80 over 2 times negative 16, which gives us 2.5. Okay, that gives me how many seconds, but I need to find the height. So to find that, I'll find f of negative 2, or f of 2.5, which if you plug all that in, I'll leave that up to you. You get 200. Okay, so after 2.5 seconds, it reaches its max height of 200 feet. Okay? There's an application problem. We'll stop there for this section.